Hi guys. So we got some more transformation stuff to talk about today. We're talking about stuff that comes from section 9.4, which is on composition of transformations. So composition of transformations really is not as complicated as it might sound. It's honestly just you're doing multiple transformations at once. All right? A composition of transformations is one transformation followed by another. So one example of this is this thing called a glide reflection. And all it really is, it's the composition of a translation and a reflection. Well, by definition, it's a composition of a translation and a reflection across a line parallel to a translation vector. So basically, if I again use my Sharpie as an example, you're basically just, you would be translating it kind of like this and then reflecting it, so you're just kind of shifting your figure a little bit before you're reflecting it. All right. So like footprints is a really good example of a glide reflection. All right. But really, like, we're just going to talk about some like vocab stuff a little bit and like maybe a couple theorems and stuff. But there's really not that much different in terms of like the content. All the transformation rules still apply. There's just going to be a little bit more that we talk about with notation. All right. So you have this quadrilateral with these vertices, and it's asking us to graph the quadrilateral itself and its image after a translation along that vector and a reflection in the x-axis. So when it says image, we're not going to graph, we don't have to graph it piece by piece, all right? When it says image, it's talking about like the final image. So the original, which I'll do in a second, and then the picture that you're left with after you do all of this. So let me graph this first. You know what? I keep forgetting. I have to move all this over to the side. Okay. So... Okay. So that's our quadrilateral. Okay. So here's the idea, right? First, we know that it's being translated along this vector. So we're going to apply the same translation rules to these original 4 points. So basically, because the y value of this vector is 0, nothing's happening to the y. All we're doing is we are adding 5 to every single x value. So b prime is going to be negative 3 plus 5, which is 2, comma 4. G prime is 4, 3. T prime is 4, 1. And S prime is 1, 2. So that's what happens after we translate it along that vector. All right? But if we're also asked to reflect it across the x-axis, we're going to take those transformations rules, or that transformation rule, and apply it to this new set of points. All right, so since we're doing another transformation on already transformed points, the notation that we're using instead of prime is double prime. Okay, so 2 little apostrophes. If you were doing 3 transformations, then it would be triple prime, quadruple prime, etc., etc. All right, but the key here is that we are doing the reflection on these new values. So if you don't remember, a reflection in the x-axis, you're flipping it over this way, so the sign on your y value is going to change. So all of these y values are going to switch, we're going to switch their signs. So 2, negative 4, 4, negative 3, 4, negative 1, and 1, negative 2. And it's these final points that are my final image points, and these are the points that I'm going to graph in my blue pen. So when I graph these, I'm going to do my double prime. And there you go. So this kind of looks like you just shifted it over a little bit and then flipped it down. All right. So that was an example of one of those glide reflections that we were talking about earlier. This next one is not. If I can, there we go. All right. But the idea is still there. Okay. Let me plot these original points. Okay. So we do have to go in the order that it specifies. So we're going to rotate 180 degrees first. Now, again, if you don't remember those rules, the 180 rotation, you're just switching the signs of all of the ordered pairs. You're not switching anything around or adding anything or subtracting anything. You're just switching the signs. So K prime is going to be -4, 1. L prime is going to be -5, 2. And M prime is going to be -1, 4. And then the reflection across the y-axis, we're going to do again to these new points. So y-axis, kind of like with the last one, the signs of the x values get switched. So K double prime is going to be 4, 1. L double prime is going to be 5, 2. And M double prime is going to be 1, 4. Okay, it's double prime, not prime prime. I don't know if I said that already. And so the double prime points are going in blue. So again, please mark your points with the prime or the double prime or whatever you're doing. And there you go. All right. Now, I know what you guys are thinking. Hey, wait a minute. Couldn't we have just reflected this across the x-axis? This looks like it's going to be just a reflection across the x-axis. You're probably right about that. All right? You know, I keep saying, like, things along the lines of, like, oh, the shortest distance to something is a perpendicular. You know, things like that. There are multiple different ways to get to the same endpoint. You know, in terms of, like, proof or traveling somewhere. You could go all these different ways, you know, all these roundabouts and still end up at the same place. This, what we did before, is just a longer way of getting to this exact same figure. When, yeah, you easily could have just flipped it over the x-axis. That would have been faster. But we're just practicing doing multiple transformations in one problem. All right? So again, this is more vocab-y stuff I just wanted to talk about. One thing we didn't mention is this idea of an isometry, which is basically just a transformation that preserves size. So by definition, its pre-image and image are going to be congruent. So if you think about all of the transformations that we've done up to this point, reflection, translation, rotation, in all of those, we were just moving things around, spinning them, flipping them. We didn't make anything bigger or smaller. So everything we talked about up to this point is an isometry. And if you're doing composition of transformations with just isometry transformations, your end result is also going to be an isometry. It's going to be exactly the same shape and size as the original figure that you just had. All right, that's all this theorem is saying. All right, so a few more problems then with just practicing, you know, composition of transformations. All right, just a bunch of different combinations. So here's our triangle. Okay, again, we're going to go in order. We're going to take our original points and we're going to translate it along that vector first. So subtract 1 from every single x value and add 5 to every single x value. So, hold on. There we go. T prime is 1, 4. U prime is 4, 3. And V prime is 2. 1. Then we're going to take all these points and rotate it 180 degrees about the origin, which is, again, just switching the signs of everything. So T double prime is -1, -4. U double prime is -4, -3. And B double prime is -2, -1. And those are the points that we're going to be plotting for our final image. If you want to graph all three, what's the word I'm looking for? Parts of this at the same time, like if you want to graph the original as well as your single prime and your double prime, go for it. All right, if that helps. Because I think when you guys get the answer key to this tomorrow, the book probably does all three. But if this was a test, I'd really only be looking for, like, the double prime at the very end. Again, I don't know, like, as of right now, you're not getting any tests on anything while we're online. I'm just saying. So anyway. There you go. Okay. So let's graph this first. Okay. Reflected across the x-axis. So as we saw earlier, the y values are going to be, the signs are going to be switched for the y values when you reflect across the x-axis. So A prime is going to be -3, -1. B prime is going to be -1, -1. C prime is going to be -1, 1. And D prime is going to be -3, 1. But before we do that, like anybody who I just said is graphing these 4 points while you're doing this, it's going to be right on top of the figure that we just did. So that's why you're also translating it along this vector to get some, like, so it's in a different place, you know? And again, we're just adding all these numbers or subtracting them from the prime points. So a double prime then is going to be -2, -4. B double prime is going to be 0, -4. C double prime is going to be 0, -2. And D double prime is going to be -2, -2. So those are the only points that I'm going to plot. I just realized that I never connected these dots. So that's where your reflection comes in, all right? The points are oriented a little bit differently than how they were in the original, all right? Okay. Same thing. We'll just plot all this. Okay. When you reflect across this line, y equals x, all you're doing to all the coordinates is just switching the values. So y becomes x and x becomes y. So J prime is going to be -2, 1. K prime is -2, 4. And L prime is 0, 3. And then we're rotating it 90 degrees about the origin, all right? It is implied counterclockwise again, so if you go back to your original rules, again, I think the rotation rules are the hardest to remember. When you rotate 90 degrees counterclockwise, you are switching the places of the x and the y, and you're making your original y value negative. So here's what I mean by that. J double prime, in that case, if we're following the rule, is going to be -1, -2. K double prime then is going to be -4, -2. And L double prime is going to be -3, 0. All right. So let's plot all this. So this is J double prime. Same thing. I was wondering, isn't this just a reflection across the y-axis? Yeah. It's just a little bit of a longer way to get there. No big deal. All right. Just a few more things that I wanted to talk about before we're done here. Just some cool theorems that I think they're cool. Reflections over parallel lines. The composition of two reflections in parallel lines can be described by a translation vector that is perpendicular to the two lines and twice the distance between the two lines. All right, so I don't think many of your homework problems talk about any of these ideas, but I do think they're pretty interesting. So what this is saying is if I have my pen, right, and I reflect it over like an invisible vertical line, and then I reflect it again over a different invisible vertical line. I mean, it wasn't a perfect flip on my part, but you can see that my pen is oriented exactly the same way that it was when it was over here. So it would have been exactly the same transformation as if I had just moved it. All right. So I'm moving it this way in the horizontal direction, which would be perpendicular to the vertical lines that I was reflecting over. That's part one. And then part two is saying, okay, so if this is the distance, the distance that I'm actually translating it is going to be twice the distance between, again, my lines of reflection are invisible in this case, but my figure is going to end up twice the distance of the reflection lines. Does that kind of make sense? You know where to find me if you have any questions on that. And then the second one. The composition of two reflections in intersecting lines can be described by a rotation about the point where the lines intersect and through an angle that is twice the measure of the acute or right angle formed by the lines. So similar kind of thing. All right? I'm going to do my best by making this invisible. But if I reflect my pen, and then I take my pen again and I reflect it sort of like a little bit over that way, where my lines kind of look like this now. Again, my pen is oriented exactly the same way, and a way that I could have gotten there with a single transformation is just by rotating it, So my point of rotation is down here, where the tip of my pen is, which also happens to be where my reflection lines intersect. And again, the angle of rotation, kind of like with the distance, is going to be twice the angle formed by your intersecting lines. So again, I don't think that there's much in your homework that involves these two concepts, but I think they're pretty cool and pretty interesting. You know where to find me if you have questions on them. But this is basically a summary of everything that we talked about in today's lesson, dealing with composition of transformations. And in terms of actually how to do it, again, I don't think it's that terribly complicated. All right? So that's it for composition of transformations. Hope you guys are doing okay out there. Stay safe, stay healthy. I'll talk to you guys soon.